Hello guys, today we'll be showing you how to do asymptotes of a function, vertical and horizontal, how to find discontinuities, and how we can solve this problem here that combines these three things. So first we need to know the math. Mathematica only helps easing up the math, but you need to know what an asymptote is. Horizontal asymptote, and I can press Alt 7 so I can type in free form, just normal text. Horizontal asymptote is the limit of a function as the function approaches infinity. Gotta see here. And then for a vertical asymptote, it is found by solving the denominator for x. And then finally, a point of discontinuity occurs when you attempt to find after you solve the denominator and you get the value of x, if you go ahead and you find, say, the functional value is f of 2, say the vertical asymptote is 2, so then if you go ahead and do the functional value of 2 equals f, the limit as x approaches 2, then you find a continuity. If they, however, don't match, then that's a point of discontinuity. So now let's go ahead and work on this example. It says let f of x be, and then a function, describe the behavior of f at each discontinuity and identify all asymptotes. So first thing we're going to do is define our function f of x, don't forget the underscore, set up the rule by column equals, and now the function is, press control divide gives you the fraction, x, control 6 gives you the power, plus 20, arrow down takes you to this part, then add 5 times x minus 2, all of that to the second power. And then once you press enter, it turns green, which means now it's in a function. Shift enter defines it as a function. So first, let's go ahead and find the horizontal asymptote, since this is the first thing we spoke about. We know the horizontal asymptote of a function is the limit of the function as it approaches infinity. So let's just do that. Let's call this variable horizontal asymptote equals, and it's going to be limit of f of x as x approaches, and then for infinity there's a shortcut, which is by pressing inf, and most symbols are like this. So press escape and then type inf, escape, gives you the infinity symbol. If you don't memorize this, you can always find it from the palette and then hover over it, and then you will memorize eventually what the symbol for it f is, which is escape, inf, escape. Now close your bracket, shift enter, and this here is your horizontal asymptote. It's basically, I'm going to press Alt 7 so I can type freeform, y equals 1 over 5. This here is your horizontal asymptote. Now onto the vertical asymptote. Let's go ahead and define a variable. Let's call it vertical asymptote, which equals, and the way we do this is again by finding the denominator of, by solving the denominator of the function equivalent to 0. So here's what we're going to do. First, let's put a cell above it, say denominator, which is a command, of f of x. Give us denominator, go ahead, copy that into here. Just copy it. Don't copy it in just yet, because we're going to go ahead and set up our solve command, which starts with a capital S, solve, bracket. Now copy what you're going to be solving. Press equal equal, which is how you set an equality. One equal defines a variable, equal equal sets up an equality, column equal sets up a row. So equal equals 0, since we're solving it for x, and then comma x. You can notice how the x turns from blue to green, because now it's going to be the product of a command. Go ahead and press shift enter, and this here is your vertical asymptote, x equals 2. If you're confused why it gives you two 2's and they're both positive, if you go ahead and do reduce command instead, you'll see it will just give you x equals 2. It also suggests that you can solve x over reals. If you do that, you will get x equals 2, which is your vertical asymptote. So now let's go ahead and check if this function is continuous or not at this point of x equals 2. So let's go ahead and first find out what the value of f of 2 is. We get complex infinity. If you go ahead and if you hover over, press on the I, gives you extra information. What is complex infinity? It's like when you divide 1 over 0, basically undefined. So we know that the functional value at 2 is undefined. Well, let's see if the limit, we right off the bat know that it's not continuous at this point. But let's say we start with the limit and we're trying to find out if the limit as x approaches 2 matches the functional value of 2. So let's find the limit as x approaches 2. So limit of f of x as x approaches 2. Close that bracket, shift enter, and you get infinity. Complex infinity and infinity are not the same thing. One is basically like saying undefined, and the other is infinity, which is different. And this was basically a brief tutorial on how you can find each asymptote of a function and whether it's continuous or not at a point of at a break of the graph. Thank you.